Alright, and this is the friction lab, and in this lab we took 4 bars that all weighed the same, and we did 3 trials to find the average kinetic force and the average static force. In this lab, right here, this is my line of best fit for my average static force, and my line of best fit for my average kinetic force. Some human errors in this lab might be the amount of force that we applied onto the pulley to find the force and like how inconsistent it might have been. Also, maybe the length of time that we pulled the bar or the distance. One trial we had to redo because the table was kind of lopsided at the middle, so one was higher than the other, so that made it kind of fall over a little bit, so we had to restart that. The math for this problem displays the change in y over the change in x, and then those are both newtons, so it's change in y over the change of x equals, for the average kinetic force at least, 0.28, and then for average static force, it's 0.75 newtons over 2 newtons, and those newtons cancel out, so you just get 0.47. Some things I might change about this lab are maybe instead of using humans, we could find some sort of remote control car or something that would be strong enough to pull these objects. Or maybe not do them on a table, maybe do them on the floor or a different surface. The objective of this lab was met because we found that the values of the average static force and the average kinetic force and compared them together, and in the end the average static force was greater because that first pull is a lot harder than when you're going at a constant rate.